Hi guys, welcome to another session of groups and conditionalities. Let's move to the first set now. So the set is there are 8 levers to a safe bank, to a safe in a bank. The conditions are as follows. One is on whenever the main or the power supply is on. So when will be the first lever be on? When the power supply is on. If the power supply is off, the first lever will not be on. None of the levers is on if the power supply is off. Lever 2 is on whenever the pin number is not input correctly. Lever 3 is on whenever the date of birth is not input correctly. 4 is on when both 2 and 3 are on. So guys, if any one lever out of 2 and 3 is off, the fourth lever can't be on. For the fourth to be on, both the levers 2 and 3 must be on. Moving to the next condition. 5 is on whenever either but not both 2 and 3 is on. So fifth lever is on whenever any one out of 2 and 3 is on. Sixth is on whenever the mobile number is not input correctly. Seventh is on whenever any two or more of the parameters are not input correctly. Now over here, what are the parameters? So there are three parameters in this set. The pin number, the date of birth, and the mobile number. So these are the three parameters. So which are the levers corresponding to these three parameters? Lever 2, lever 3, and lever 6. So for the lever 7th to be on, any two or more parameters must satisfy. Or I can say that for the lever 7th to be on, any two lever must be on out of 2, 3, and 6. Next condition, 8 is on whenever all these parameters are input incorrectly. Lever 8 is on whenever all these parameters are input incorrectly. Now let's move to the questions. So this is just a chart which gives us an idea about the conditions. So the main power supply must be on for all the other levers to be on. And then the conditions follows. Move to the question. How many of these 8 levers can be on at the same time at the most? Now, at the most means maximum. So the question is maximum how many levers can be on at the same time out of these 8 levers? So now we have to keep maximum levers to be on. It's up to us, right? We have to keep the maximum levers on. So let's see what we'll do. Now, obviously, the first lever has to be on because it's the main power supply. Now, we ourselves have to keep the maximum levers on, correct? So, this second and third lever as on. Now, if I on the second and the third lever, the fourth lever will automatically be on. If I on the second and the third lever, the fourth lever will be automatically on. And the fifth lever will be off. The fifth lever will be off. Now, for the sixth one, I'll keep it on. For the sixth one, I'll keep it on. If second, third, and sixth lever are on, that means I can say that the three parameters, all the three parameters are satisfied. Hence, lever 7 has to be on because lever 7, the condition is Any two parameters must satisfy. And over here, all the three parameters are satisfying. Hence, lever 7 has to be on. Now, what about lever 8? Lever 8 will definitely be on. Why? Because all the three parameters are satisfying. If all the three parameters are satisfying, I can say that lever 8 will definitely be on. Hence, how many levers are on? So, in all, 7 levers are on. Just one lever is off, that is the fifth one. Hence, I can say that at most 7 levers could be on. So, 7 is the answer. Guys, you just have to look for the conditions and try to apply some logic. The set is very easy. If you're clear with the conditions, you will definitely get the questions. Let's move to the next question now. If lever 5 is on, then which of the following levers are definitely off? Now, lever 5. When will lever 5 be on? The condition says that one out of lever 2 or 3 is on. Only in that case, lever 5 is on. This is the condition. But guys, do we know that which lever out of 2 and 3 has to be off and which lever has to be on? Obviously, we don't have this information. They have just said that any one lever must be on. That lever could be 2, that lever could be 3. Hence, we can't definitely say that lever 2 is on or lever 3 is on. We can't definitely say anything about 2 and 3. Hence, 2 and 3 are ruled out from the options. Now, let's see. Now, lever 5 is on. Main power supply is on. We don't know. Any one out of these must be on. But I can definitely say that lever 4 is going to be off. Why is lever 4 going to be off? Because lever 4 needs both 2 and 3 to be on. And we know that any one out of these two levers is on. Hence, lever 4 is definitely off. So we got one lever that is definitely off. So that is lever 4. Now guys, just refer to the eighth condition. Condition for lever 8. For lever 8, the condition said all the three parameters must satisfy. But over here, out of 2 and 3, any one lever is off. Hence, the parameters will never be satisfied. So, lever 8 is going to be definitely off. Hence, we got the answer as lever 4 and lever 8. So, these two levers are definitely going to be off. Moving to the next question.
Hi everyone, let's look at the next set, which is groups and conditionalities. So please pause this video right now and read the question, and then we can start with the solution part. Okay, so what do we have? So we have a group of 6 boys, which are PQRSTU, and 5 girls ABCDE, and we have to form a team of 6 members, and following are the conditions. So when I come across such type of question, something like this that I have done on the side, something like this I prefer to do just to keep a track of all the conditions that I have to follow while forming up the teams. So let's look at the question straight away. So the first question that we have is this: if the team consists of 4 girls, the members of the team are. So what I would suggest actually is that basically unless and until they are not asking you to form the teams, then please do not worry about forming the team actually, and you can just quickly eliminate the answer option. So if I'm eliminating the answer option, I can clearly see that Q and T cannot be teamed together because it was one of the conditions from the previous things, as you can clearly see. So I don't need to even bother looking at that particular team. So something like this you can follow very quickly, and you will see that there's only one answer option which will be staying at the very end. So second answer option, why it is eliminated? So I can see that C is there, but Q is not there. So basically that is why it is eliminated. Fourth answer option, R and B have to be together. So R is there, B is not there. So that is also eliminated. So answer has to be answer option 3 as far as this is concerned. So I hope you can understand that how quickly you can solve this question without missing out on information. So you don't need to do all of this unless they are asking, how many teams can be formed and all. You don't need to form. You can just eliminate the answers and answer the question very fast. Next question. If the team consists of 5 boys, then there is only one girl, then the girl has to be. So again, we can do reverse engineering. 5 boys, and we have to form a team of 6 people. That means the sixth person has to be the girl, and which is very clearly as well given. And we have 6 boys for the select, and we have to select 5 boys. That means we have to always ignore one boy. And again, what you can do is again use the elimination. So with that approach, what you can clearly see that B has to be the girl with which we should go ahead, because R and B have a scenario. So if we select B as the girl, R will be selected by default because of their restriction. Next question. If the team consists of 4 boys including T, and if you remember, T had a couple of conditions, which is Q and T cannot be teamed together. So I can clearly see that this gets eliminated and this also gets eliminated because T is selected and Q and T cannot be together. So these two are gone. This one is also gone because S and A cannot be together. That means for me answer has to be answer option first very clearly. No need to bother doing all of this. You can very quickly eliminate the answer options. Fourth one, if the team consists of 3 girls including A, and if you again remember, A has conditions that it cannot go with S. So this is eliminated. This is eliminated. Why this one is eliminated? Because they have gotten R, but B is not there. So that means this is also eliminated. So that means answer has to be this one. Okay. Last question from this one. If the team including R consists of 4 boys, so R is selected and R has only one condition, that if R is there, B should be there. So B is not here, eliminated. S and A can go together, S and A cannot go together. So this also gets eliminated. Gets eliminated because B is not there. Here B is there, but SNA is there, which is going to spoil the condition, which is going to not go ahead with the restriction. So this is eliminated. So that means answer has to be this one. So again, there's one more learning out of this set is that you don't need to form the teams and spend more time in such question unless they are asking you to form the teams. You can just quickly use the method of elimination. Thank you.
It is said that a team is to be selected from 5 men, P, Q, R, S, and T, and 6 women, A, B, C, D, E, and F, where P, Q, and C are lecturers, R, S, A, B, and D are engineers, and the rest are doctors. The team should be selected subject to following conditions. First condition, Q cannot go with S and C. Second, R and E have to be together. Third, P, A, and F have to be together. Fourth, S and A cannot be together. Fifth, T and B have to be together. Sixth, R cannot go with B. So these are the people that we have. So P and Q are lecturers, R S engineers, T doctor. This is a men category. Women category, it has C as lecturer, A, B, D as engineers, E and F as doctors. These are the conditions that we have plotted according to the given conditions. Now we will always refer to these plotted conditions and then we'll refer to the question. First question says, if the team consists of one lecturer, two engineers, three doctors, R does not go with E, the member of the team are. Now, in this question, we have one more condition that R does not go with E. So we have to move to the conditions which we have plotted. So R cannot go with E. Now, in the question, it is said that we want one lecturer, two engineers, and three doctors. So let's try to find out the team. Now, first, we need three doctors. So what we'll do is, we'll select all the three doctors because we have only three of them. So we'll select all the three doctors, that is E, F, and D. Now, if F is selected, P and A will also be selected. If T is selected, B will also be selected. Hence, this is the team that we have. So the final team is PTABEF, that is option 3. Moving to the next question. If the team consists of one lecturer, three engineers, and one male doctor, the members of the team are. So we want one lecturer, three engineers, and one male doctor. So one male doctor. We have only one male doctor, that is T. So we'll select T. Now, if we select T, we have to select B also. Now, if B is selected, R cannot be selected, and R and E are together. Hence, E can also not be selected. Now, we want one male doctor. So, if we want one male doctor, we cannot select female doctors. Hence, E and F will be eliminated. So, these possibilities will be eliminated. Now, we are just left with these members. Further, we need three engineers. Now, B is already an engineer. There are two more engineers remaining, that is S and D, so we have to select both of them. If S is selected, Q cannot be selected. Hence, among the lecturers, we can only select C. So the team is formed. Moving to the next question. If the team consists of two male lecturers, two lady engineers, and one doctor, the members of the team are. For two male lecturers, we only have two male lecturers, that is Q and P. So we have to select both of them. Now, we also have to consider all the statements that we have plotted. Q cannot go with S, Q cannot go with C. P goes with A and F. That means if P is selected, A and F will also be selected. If Q is selected, S and C cannot be selected. Now, S is not going with A, so we'll eliminate the possibility. We want one doctor, and one doctor is already selected, that is F, so we'll eliminate these possibilities. And we want two engineers, so we are only left with one engineer, that is D. And hence, after selecting D, the team is complete. So PQADF is the team that we'll select. Moving to the next question. If the team consists of two lecturers, two engineers, two doctors, and not more than three ladies, the members of the team are. So we want two lecturers, two engineers, two doctors, and not more than three ladies. So two doctors. Now, we don't want more than three ladies. This is also one of the conditions. So what we can do is we can select any one of E and T. we can select any one of E and T. If we select F, P and A have to be with F. Now A cannot go with S, so that possibility will be eliminated. Now we want maximum 3 ladies. So as we want maximum 3 ladies, C cannot be selected. And we'll select Q in the team. Hence we can say that PQADF is the team that we have. Now we can select any one of E and T. So according to the options, we will work and we will select the members. Moving to the next question. If the team consists of one male lecturer, one male engineer, one lady engineer, and 2 doctors, the members of the team are. Now we want 2 doctors. So we can again select any one of E and T. We'll by default select F. So if we select F, P and A will also come. Now A and S are not going together, hence that possibility will be eliminated. We want one male engineer, so we have to select from R and E. So we'll select R. If we select R, E will also go in the team. And this is the team that we have got. So the option is option 3, that is PRAEF. Moving to the next set. While formulating a college volleyball team, the following points have to be noted. There must be one captain. 2 students are required to take the front positions. 2 students are required to take the defense positions. The 5-member team must be made out of short list of students of P, Q, R, S, T, U, V, and W. The captain can be one out of R, S, and T. The 2 students who will take the front position can be the 2 out of P, Q, and R. The defense position, the defense will be positions will be the defense positions will be taken by 2 people. Possible students for this are U, V, and W. P and R like to play with each other. T and U are always together. Now, eighth condition says P and R like to play with each other. This means P and R are together. Moving to the questions. So first we'll try to plot the conditions given by them. So these are the captain, these are the front position players, these are the defense position players. Now, P and R have to be together and U and T have to be together. So let's try to form the team. Now, if captain is R cannot play at the front position because R is the captain. Hence, for the front position, we will select PQ. As we are not selecting U, T will also not be selected, so VW will be the defense players. Second condition, S as the captain. If S is the captain, at the front places, P and R will play, and V and W will play as the defense. If we select P, we can select PR because they are together, and at the defense position, we have to select U, and we can select any one out of V and W. So there will be 2 possibilities. That is, first possibility we'll select UV, and second possibility with the same team we'll select UW. So these are the 4 teams or 4 possibilities that we can find. Moving to the questions. Which combination is not possible if all preferences are to be met? So if all preferences are to be met, we have to select which is not possible. Now, first option says R captain, P and Q at front. So first is satisfying. Second answer option says Q and R at front position. Now Q and R cannot play at front position. Hence option 2 is the answer. Moving to the next question. If P and Q are to take the front positions, which of the following is necessarily true? First, R will be the captain. Second, U will take defense position. Third, V and W may take defense positions. So, P and Q can take front position, yes. that is following. Further, R will also be the captain, that is also following. Hence, P and Q, if they take front position, R will be the captain, and V and W may take defense position. Hence, we only have to refer to the first possibility. According to first possibility, we can say that option 3, 1 and 2 conditions are satisfying. Moving to the next question, how many teams are possible if all the preferences are met? We have already found this answer. If all the preferences are met, that means if we have to follow all the conditions, we can form 4 teams. Next question, if no preferences are to be allowed, this means if we don't have to follow any of the conditions, what is the number of possible combinations to work with? So, how many teams can we form if there are no conditions? So let's look at it. Now for defense, we can have these 3 possibilities, UV, VW and UW. R as the captain. At the front, we can have these two, that is P and Q, because R is already the captain. Hence P and Q have to be at the front position. So we can form 3 teams by considering R as the captain. By considering S as the captain, we can form more teams because at front position we have these 3 possibilities, that is PR, PQ and QR. So hence we can form 9 teams when S is at the front, when S is the captain, and we can form 9 teams when P is the captain. So the teams would be SPRUV, then second team would be SPRVW, then third team would be SPRUW. Same follows for the other possibilities. Hence total of 21 teams can be formed. Moving to the next question, if P and T are chosen, the other members of the most preferred team will be. So if we choose P and T, we have to select the other members of the most preferred team. So we have to go with the third and the fourth possibility. If you observe, if P and T are there, then RUV and RUW, these are the most preferred team members. But RUW is not there in the option. Hence, we will select RU and V, that is option 2. Moving to the next set. In a cricket selection camp, the coach wants to select 4 players out of 7. 3 players A, B, C are all-rounders and the rest D, E, F and G are bowlers. To add extra strength to the team, always 2 all-rounders must be selected. There are few other restrictions also, which are B cannot be selected with D, C cannot be selected with F, F cannot be selected with G. So we need 2 all-rounders, 2 bowlers, and these are the conditions. B cannot go with D, C cannot go with F, F cannot go with G. Let's move to the question now. So if F is selected, then who are the other members who can be selected? So if F is selected, that means F is there in the team. If F is selected, C and G cannot be selected. Hence, we will eliminate their possibilities and we need 2 all-rounders. So A and B will definitely come in the team and E will also be in the team. Hence, A, B, E, F is the team that is formed. Moving to the next question. If B is not selected but G is selected, then who are the other members who can be selected? So B is selected but G is not selected. Now if B is selected, D and G cannot be selected. This is what we have. Okay, if B is not selected but G is selected. So B is not selected but G is selected. That means B will be eliminated and G, I'll put G inside the team. Now we want 2 all-rounders. So there are only 2 all-rounders left, that is A and C. So we have to select them. Now C cannot go with F. And we are only left with 2 bowlers, that is D and E. But over here we can select any one bowler out of these 2. That is, we can select D and we can also select E. There is no restriction as such for this. In the options, D is there, D is given. Hence, we will select option 2, that is A, C, and D. So in such type of questions, you have to work with the options. Moving to the next question, if B cannot be selected with C, and if E and G are selected, then who must be selected? Now B cannot go with C. Now E and G are selected, so I'll put E and G in the team. So we have already selected two bowlers. Now we need to select two all-rounders. So A will be there definitely, and we can select anyone out of B and C. A is there in the option, hence A is definitely a team member. So as A is definitely a team member, we will select A in the option, from the option, that is option 3. Moving to the next question, a complex system of three valves, A, B, and C, each of which can either be open or closed position, always meet all the following conditions. If C is open, then either both A and B are open or both are closed. If B is closed, then one of A and C is open and the other is closed. If A is closed, then either both B and C are open or both are closed. One of the valves is always open. In all the situations where the above conditions are met, which valve is this one? Now, it is said, let's take the first possibility. Let's go with the first possibility. Now, it is said that if A is closed, then either both B and C are open or both are closed. Now, let us focus on the A part first. First condition also says that if C is open, then either both A and B are open or both are closed. And the second condition says if B is closed, then one of A and C is open and the other is closed. Now, if we keep C as open and if we keep A and B both as open, these are the conditions that we'll get. So basically C, B and A, all three are open. But now we'll check whether it is meeting all the conditions or no. So if you observe, there are two possibilities. That first possibility is if C is open, both A and B are open or both are closed. So these are the two possibilities that we have. Now, in each case, C is open, but we have to cross-check by considering the possibilities of A and B also, the conditions of A and B also. Now, according to the given conditions, in the second way, it is said that A is open and then C is closed and B is closed. So let us again refer to the conditions given. So these are the two conditions about C. Now, we have already followed the first condition. So let's move to the second and the third condition. If B is closed, then one of A and C is open and the other is closed. If A is closed, then either both B and C are open or both are closed. So according to the third condition, we can definitely eliminate the second possibility because according to the third condition, according to A's condition, we can eliminate that. We can say that the second possibility is eliminated. In second possibility is definitely not the answer because if A is closed, then we have to make B and C open or both closed. Both open or both closed. But that is not following. In second possibility is eliminated. Now if we keep A as open, then C and B both are closed. This is what we have known. If we keep A as closed, then we have to keep B and C as open. If we keep A as closed, then we have to keep B and C and B also as closed. So these are the conditions that we have. Now this possibility we have already eliminated. So let's move to the next possibilities. According to the given conditions, if we compare the condition of B and C with A, then we'll get to know that we have to eliminate the third possibility also, because all the three valves cannot be closed. They have said that one valve is always open in all the cases, hence third possibility is directly eliminated. And if you observe in both the possibilities that are left, A is always open. So hence option 1 is the answer, because A is going to be open in all the possibilities. Thank you.